Today we're going to try something a little different. What we're going to do is I'm going to show this video in class. We can stop this video at any time and talk about any of these questions, but I'm just going to kind of go through the work that is necessary on map number 3 in order to get to your solution. So number 1, a square has more rotational symmetries than an equilateral triangle. Here we're trying to find which statement's not true. So we want to go through each statement, see which ones are true, and we can rule those out. So if we look, the first one says a square has more rotational symmetries than an equilateral triangle. A square has 4 rotational symmetries. An equilateral triangle has 3 rotational symmetries. So we see that this one is true. B, a square has more rotational symmetries than a non-square rectangle. A square again has 4. A non-square rectangle will only have 2. So again, this one is true. A square has more rotational symmetries than a regular hexagon. A square has 4. Based on our previous knowledge, an equilateral triangle had 3. A square had 4. A hexagon, based on that, has 6 sides, so it's going to have 6. This one is not true. Anytime we're looking for one that's not true, though, we want to make sure that every other one is true. So a square has more rotational symmetries, 4. Then it has lines of symmetry. Here's our square. Here's a line of symmetry. Here's a line of symmetry. So it has, if you count these, 4 lines of symmetry. So that tells us that this, in fact, is true. Moving to number 2. A radius of 3. Remember, radius is from the outer edge to the center of the circle. We're looking for the distance around the circle. That means we're looking for circumference. And circumference is 2 pi times the radius, or pi times the diameter. Notice 2 times the radius is the same as the diameter. Okay, so using this, since the radius is given, I'm just going to use the one that has the radius in it, radius of 3. So here we have c equals 6 pi, combining like terms. Usually pi is given as 3.14. So we're just going to do 6 times 3.14. And we get 18.25, I believe. We look at our answers. The closest one is 19. Number 3. A scale on a map shows 2 cities are 150 kilometers apart. Scale says 3 centimeters for 25 kilometers. Okay, we're looking for how many centimeters it is on the map, and it's 150 kilometers. So we do 150 times 3, which gives us 450. We do x times 25, gives us 25x. We divide both sides by 25. And we get 18. And we need centimeters on that. And that's one of our answers. Okay, Jody wants to rent sports equipment to people at the park. She needs to know the equipment that will rent most often. What's the best method to gather information? Okay, the one says observe the equipment that most people buy at a sports store. That's not necessarily telling us what they use at her park. Survey adults at the library on Saturday afternoon. Also, nothing really to do with her park. Survey elementary school students on the playground. Okay, that doesn't really, again, have anything to do with the park. Observe the equipment that most people rent at different rental stands. I believe this is the best answer because it does, in fact, talk about what people rent at the park. Number 5, Kyle is 3 years older than twice his sister's age. His sister's 5 years old. How old is Kyle? So what I'm going to do is I'm going to put Kyle is
3 years older, that means plus 3, than twice his sister. And I'm just going to use S here. This represents Kyle's age. We know his sister's 5, so we plug in.
We do the work. Kyle's 13. Okay, here the diameter is 20 yards. We're given an area formula that involves radius. Remember, radius is half the diameter, so if we use half the diameter, we use 10. So right at this point we get 100 because we do 10 squared. It's times pi. And if we do 100
times 3.14, we end up with 314 yards. We're talking about area, so it is squared. And that is answer B. Simplifying the expression. Remember PEMDAS. Okay, parentheses first, -1 plus 7 is positive 6. Minus 3 times whatever's in this parenthesis is a -3. So now we have 6 minus whatever 3 times -3 is -9. We change the sign on both of these, and we get 15. The pizza deal. Buy a first pizza for $12. Each additional for $6. Okay, so if we bought one pizza,
we're going to look at this for different cases. One pizza, we would have $12. Two pizzas, we would have 12 plus our additional 6. Three pizzas, we have
$12 for the first pizza, 6 for each after that, so we end up with 24.
And 4 pizzas, 12 plus 18 gives us 30.
So using this, we know 12 is always going to be constant. So C is our number, or our total cost. 12 is always for the first pizza.
If we add the cost of each additional, so we think that that means probably $6 for each one. Now we want to plug things in. We want to say if we have one pizza, is it $12? If we plug 1 in for n, we get 6 plus 12, which is 18. So we're 6 too many. And again, if we do 2, we get 12 plus 12, which is 24. We're 6 too many. So what I'm going to do is I'm just going to try subtracting 6. Combining our like terms.
And if we try this for each of them, it does in fact work. Next one, plotting the points. Okay, I'm going to quickly plot these. Remember, x is first, y is second. Okay, identify the shape. It is a square. We know that because it's 4 equal sides, and they are also parallel. Okay, draw lines of symmetry. Here is one line of symmetry. Here is another line of symmetry. Since it's a square, we know that it also has this diagonal line of symmetry. And it also has this diagonal line of symmetry. So it should have 6 lines of symmetry. Okay, on number 10, we're just going to have to plot the points. We plot all of these points.
Okay, the first set
makes a straight line, so we know that one's no good. Second one, I'm doing these in different colors. Just have to do something to denote it, or you can erase it if that helps.
I believe the second one's kind of a no-brainer because it has 4 points.
But just to make sure, you never know. The third one, it again has 3 lines that are currently, or 3 points that are currently in a line. And our final one, we hope it's correct. If it's not, we have to go back through and make the corrections. That was actually plotted incorrectly. 3, 4, and 6, 2.
We can see that these lines do in fact make a triangle.
So we want to make sure that that last one,
Even if it's not, even if it's the only one that we think could be possible, we still want to check it to make sure.